So let's go through some examples for the index laws. I've got the example sheet here, and they start off quite easy with multiplication, easy division, and they get harder as they go along. You can see some of these here, they use multiplication and division in the same one. And then as we get further down, we're going to use negative indices, multiplication and division all in the same one. Down here, we look at roots. We're going to keep going to look at variables as powers. And right down here, we're going to use all that to solve for x. Okay, index laws, they do get taught early on, but you kind of don't use them all together until now. So make sure that you're practicing a lot of the questions that are complicated, not so much these first ones. Okay, so you won't typically get a question like that. If you do get an index law question, it might look something like this one here. Okay, or it might look like that. Or it might be part of a bigger question that you've got to use those laws to find. So let's go through it. The first one. So what I do first, I have my formula sheet beside me here. This is on the back page at the top. So I first look at which one does it look like. So here I've got two bases. So the letter down the bottom is the base, and I'm multiplying. So I'm using this first formula here. Okay, so when I multiply, my answer, the base is the same. So the base stays as b, okay, and I plus the powers together. So 3 plus 3. Okay, so it's b to the power of 6. Okay, you don't have to show this working, that's just me explaining it to you. Okay, so you could go straight in that case to b to the power of 6 and it will be fine. So let's try the second one. Now, the order I typically do it in, so I don't forget anything, is numbers first and then alphabetical order. Okay, these numbers here are not in indice form. That is, they don't have a base to a power. Okay, if they did have a base to a power, you would treat them the same way as you would any other indice. Okay, you could use the index laws, but when they're not indices, aren't. Okay, so we're just going to treat them like normal numbers. So 2 times 8, okay, which is obviously 16. Okay, so numbers first, alphabetical order. So a to the power of 2 times a to the power of 3. The base stays the same. We're using this first index law still, and we add the powers. Okay, then we go to the b's. We're multiplying again, so we add the powers. Okay, and then the next line down, I'm going to bring it all together. So 2 times 8 is 16, a to the power of 5, b to the power of 9. Again, you don't need that much working. You can just skip straight to the answer. Okay, so numbers first, then alphabetical order, and that's the order that you write your answers in as well. Okay, that's the proper communication, proper way to write it. Numbers first and then alphabetical order. So let's go down a little bit here. So this is the same kind of thing, it's just a little bit bigger. We're going to start with numbers first. So 4 times 2 times 3. Okay, and then my letters in alphabetical order. So I'm going to go my m's first. So m to the power of 2 plus 4 plus 0. Okay. You might like to cross them off as you go along. I don't typically, but some people prefer to. Okay, and then we're going to go n to the power of 4 plus 3 plus 7. Okay, so if it's a big one and you're worried that pieces are going to get lost, you can cross them off as you go. So next line down, I'm going to simplify that. 4 times 2 is 8, times 3 is 24, m to the power of 6, 2 plus 4 is 6, plus 0 is still 6, and n to the power of 4 plus 3 is 7, plus 7 is 14. Okay, so that multiplication one, you just need to make sure that the base stays the same, and where that might be tricky is, like I said before, if you have your bases and numbers like this, what a lot of people do is they'll times the base and then add the powers, which is not correct. Okay, the base, as you can see in the formula, the base stays the same, so it stays 4, and we just add the powers. Okay, so just be aware of that. People don't typically get confused with the letters, but the numbers throw a few people. So just be aware of that, that the base stays the same. So that's multiplying in its simplest form. So when we multiply, we just add the powers. What I want to do though is just go back to this one here, and just show you an alternative. Okay, so there's a bit of wording with this. This here would be what's called evaluating. So we've taken 2 times 8 and we've just evaluated it. We've figured out what the answer is. The alternative to that is sometimes they will ask you to simplify it, or they might ask you to write your answers in index form. Okay, so the B is in index form, the A is in index form, but the number isn't. Okay, and there's 2 ways we can do that. We can look at 16 and try and figure out what it would be as an index. So it's going to have a base of 2. 2 times 2 is 4, times 2 is 8, times 2 is 16. So it would be 2 to the power of 4, A5, B9. So you can do that at the end if it asks you to write your answers in index form, just by working out, it's normally only a base of 2 or 3, or maybe 5 that they'll do it. Or we can figure it out earlier on. So when we do the numbers 2 times 8, we can change that 8 there. So 2 is fine, 2's to the power of 1, that's okay, it's got a prime number as its base, but 8 can actually be rewritten as 2 to the power of 3. Okay, 2 times 2 is 4, times 2 is 8. Okay, and then when we simplified, we would add the powers, 2 to the power of 4. Okay, so just be aware of that. Some of the more complicated ones, I'll see if there's one down here, will have a different base. Yeah, like this one here. See how it's 3 to the power of 3, 3 to the power of 2. If you change that to 27 and 9, you wouldn't be writing your answer in index form, and you probably wouldn't be simplifying it as fully as possible. So when you come across something like this, just leave it in index form for as long as possible. Okay, is there another one down here? This one too. We could write all of these as base 2s. Okay, and we'll get to that a bit later on when we do the whole question, but just be aware that you may be expected to rewrite some numbers in index form. Okay, so let's move on to our division examples. So it starts off pretty simple. We can see we're using this second index law here. I know that because I've got my 2 bases that are the same and they've got a division between them. Okay, so following that formula, I'm going to keep my base the same, so the base is going to stay 3, and I'm going to take away the powers. Okay, so 3 to the power of 11. Now, if it said something like simplify or write your answers in index form, that's your answer. If it says evaluate, you need to pop that into a calculator and get an actual number, which is going to be huge, and I don't have a calculator on me. But it's going to be 3 times 3 times 3 times 3 times 3, 11 times. Okay, so simplified is this one here. Evaluating is where you get a number. Just be careful of watching that language, what they use. Okay, let's try the second one down. 60x to the power of 3 divided by 3x. Now this here is a fraction bar, which means divide. So we're still looking at this same formula. We're dividing. And if that confuses you, you can write it just as we've seen the other ones. Okay, the fraction bar is just there to mix it up, really, just to confuse you a little bit. Just be careful if you've got a couple of terms on the front that you put brackets around everything. So we're going to do the same process. We're going to do numbers first, then alphabetical order. So 60 and 3, they're not in index form, so we just treat them as normal. 60 divided by 3 would give us 20. Okay, x to the power of 3 divided by x to the power of 1 would be x to the power of 3 minus 1. So we've got 20x squared. Okay, whenever you see a letter or number without a power, it's always a 1. Okay, never a 0. It's a different rule, which you can see down here. It means something different. It's always to the power of 1. Okay, so we're moving on a little bit here. We're looking at some problems that aren't as simple. So this one here, it's got a multiplication, so I'm using the first index law, but it's also got a fraction bar, which is the division, so I'm using the second index law as well. Okay, same thing with the one below, we're going to use multiple. Now, the way I always approach fractions, not just with index laws, but any fraction, is I simplify the numerator first, then simplify the denominator, and then simplify the whole fraction. Okay, so in this case, to simplify the top, I'm going to go numbers first. There's nothing to multiply 3 by, so it's just 3. I'm going to go A6, Y4, and then I'm going to simplify the bottom. So 6 times 3 would be 18 x cubed y squared. Okay, with this question here, that's one way to do it. You can also simplify down from scratch. Just be really, really careful that if it's got a plus in it, you can't just knock terms out here and there. Okay, so I'm going to do it this way first, and then I'm going to show you the other way with the same question. Okay, so I've got it to here. I've got my numbers here, 3 and 18. Now, 3 doesn't divide by 18, so I need to find a common factor that they both have. So 18 and 3 both divide by 3. Okay, so 3 divided by 3 is 1. 18 divided by 3 is 6. Okay, so it stays with the fraction, especially if the number below is bigger. Okay, my A's, I haven't got anything to divide them by, so they're just going to stay there. My Y's, now I've got Y's on the top and the bottom, so I can simplify. So I'm going to go y to the power of 4 divided by y to the power of 2. Y to the power of 4 minus 2, y to the power of 2. Okay, I've got 2 more y's on the top than I do on the bottom, so I put the y's on the top. Okay, that one takes a little bit of getting used to the cancelling down, so just do it one at a time, one letter at a time. Okay, I've dealt with all those. I haven't dealt with the x to the power of 3 yet. That just stays on the bottom, not very much. Okay, so that's one way you can deal with it. Another way you can deal with it is from the get-go. You can say, well, I've got a 3 on the top, a 3 on the bottom. They cancel out. Okay, so I'm left with on the top, oh wait, I've got y's here. I've got 2 down there and 4 up there, so I can get rid of 2 here, and I've got 2 left up there. Okay, and then write my answer. So I've got A6, Y2 left on the top, and 6x3 written there. Okay, you'll notice that that way is a lot quicker. It is though prone to a few more mistakes, so just make sure if you're doing it like that, you're doing it carefully and maybe crossing off as you go to make sure you're getting everything. So I'm going to do the same thing with the next one down. I'm going to do it simplifying the top and bottom first, and then I'm going to do cancel. Okay, you can see down here why I like to simplify the top and bottom rather than cancel, because that can be pretty messy. So here I'm going to go numbers first on the top. So 10 times 2 is 20. I'm going to sort out all my A's on top. I've got 2 there and another one there. So I've got A to the power of 3. I've got 3 B's there and another there. I've got B to the power of 6. Okay, and then down the bottom, numbers first. 15 times 2 is 30. A to the power of 7, A to the power of 1. I've got 7 there, another one there. I've got 8. I've got 2 B's there and another 4 there, so I've got 6. Okay, so now I'm going to simplify. So once my numerator and my denominator are just one term, I simplify from there. So I need something that 20 and 2 is quadratic. So I've got 4 on the top and 3 on the bottom. I've got 3 A's on the top and 8 A's on the bottom. And I have 5 more A's on the bottom and I 2 on the top. Okay, this is the way I like to start. I have more on the top and more on the bottom. So how many? Okay, these are the power of 6 on the top, 6 on the top, so they actually cancel out. So that's kind of good. I'm going to begin using that cancelling out area. So the first thing I'm going to take is that stop what you're doing and do this one. So I can see I can I can see 1A and 1A, so they disappear. What else can I see? I can see there, 2 there, that'll leave 1. I can do the same thing here. I've got 3 there, 4 down the bottom, so I can just do that. My A's, 7 down the bottom, I can get rid of that. Make 5. And that looks pretty good. So I've got 10 B1 over 15 A5 B6, and I've done something wrong already. Oh, that's not 6. Sorry. So that is B there. That one went. My pens are taken both ways. So that one went, and there was one left up there, and then there's this one here left. Okay, so I've got here, now I've got to simplify again, these ones on the bottom, and I need to find a number that's 10 to 16, so I divide 2 over 3 A5. Okay, so that one can be quicker. Did you see how messy it was? And how I kind of forgot them. So if you're a slow and steady person that likes order, this one, that one will always work. If you want to sort the two, you can use that. You can use a combination of both. Okay, just make sure you're really clear as to what you're including and what you're. Okay, so this is where it gets pretty messy. So I'm just going to steal my formula sheet from back up here so you can see what I'm talking about. Okay, this one includes multiplication and division. It also includes some other index laws. So let's see what we can find. We know it includes multiplication because there's a multiplication sign. It includes division because there's a fraction bar. This one here, raising a power to another power. Yep, it's got that one too. Okay, and it's also got negatives. So this one takes into account 4 different index laws, but we're going to use the same technique as I did before in the blue. One step at a time, I'm going to sort out the numerator as much as I can, and I'm going to sort out the denominator. Okay, so BODMAS applies here as it does with everything else. We're going to do brackets first. So up top, the first thing we're trying to get rid of is the power up here, and we need to figure out how to raise a power to another power. Okay, so this is my index law over here. When I raise a power to another power, my base stays the same, and I multiply powers. So the 3 there, that's a little 1, remember? So it's 3 to the power of 1 times 2. A to the power of 2 times 2, and B to the power of negative 3 times 2. So that 2, that power outside the bracket, goes on each and every letter and number inside the bracket, okay? Including if they don't have a power written on top. So then I go times, I'm looking here, remember if it doesn't have a power, it's 1. So I've got A to the power of 1 times negative 1, B to the power of 2 times 1. Okay, and my denominator, the same thing, a little invisible 1. So 3 to the power of 1 times 3, A to the power of 1 times 3, times B to the power of negative 3 times 4. Okay, so cancelling is not an option here. It's there's quite a few steps. Unfortunately, there's not a shortcut. So we are going to simplify those. So we're going to go through 3 to the power of 1 times 2 is 2, A to the power of 4, B to the power of negative 6, A to the power of negative 1, B to the power of negative 3, 3 to the power of 3, A to the power of 3, B to the power of negative 12. Okay, so done a little bit of simplifying. We're going to do a little bit more if we've got some room. Kind of. Okay, so I'm going to keep, see how this isn't simplified yet? I've still got A's and B's all over the place. So I'm going to keep filling out the top and the bottom until it's quite neat. So I've got 3 squared up there, and I've got A's. Now I'm multiplying. So it's going to be A to the power of 4 plus negative 1 is 3. Okay, going to be b to the power of -6 plus -3, because when we times, we add. Okay, -6 plus -3, b to the power of -9. Okay, and down the bottom, 3, 3, a, 3, b, -12. Okay, so that's looking better. I've only got kind of one set of A's and B's on the top and the bottom. It's time to start cancelling down. So my thought process now would be numbers first in alphabetical order. So I've got 3 here and 3 here. I've got 3 A's down the bottom. I've only got the top, which means I have 1 more 3 on the bottom. Okay, so 3 to the power of 1 or just 3. I've got 2 A's on the top, 2 A's on the bottom, they cancel out. And then I get to the B's, and this is where things start getting a bit harder. So I've got negative powers, which if you can see over here with my rule here, a negative power, you want to change it from a negative to positive, you have to cross the line. Okay, so if this is a -9 up the top and it crosses the line to the bottom, it becomes a positive. Okay, so when it drops below the line, the power turns from a negative to positive. Cross the line, change the sign. Okay, this B12 down here, I'm crossing the line from the bottom to the top, cross the line, change the sign. Okay, and then I can cancel as normal. So B's on the top and the bottom. I've got more B's on the top. How many more? I've got 3 more. Okay, so that question is more along the lines of what you'll get in a test, and it just takes practice. Okay, so I think there's another one similar a bit later on, yes. But if you're not comfortable with that, go and have a look at the further practice questions. And there's also a Year 9 exam that has a look at the same kind of things. So just keep practicing them. It'll make the rest of the unit a lot easier. Okay, the rest of these ones I'm going to add into a separate example video. So can you make sure that you've practiced this all together? So print out that exam and run through it before we move on, because these ones down here, if you're not 100% comfortable with fractions or you haven't done much with surds, are going to throw you off a little bit. So practice those ones first and then watch the next video for the next lot.